Okay, this is what a hyperbola looks like. It basically looks like two parabolas graphed on the same graph. You have one opening this way to the right, and then you have another one over here opening to the left. That is known as a horizontal hyperbola because it opens right and left. Okay, does everybody see how this is opening right and that's opening left? So that's why this hyperbola is a horizontal hyperbola. A vertical hyperbola is like two parabolas, but one opens up and one opens down. So does everybody see the difference between a horizontal and a vertical hyperbola? Okay, well, because there are two different types of hyperbolas, there are two different equations. Horizontal means the x will come first. Vertical means the y will come first. Now, why do you think on the smart board it's just x squared, y squared, and then y squared, x squared, but on the whiteboard I went ahead and wrote y minus k, x minus h? Correct. For the next couple of days, we'll only be working with hyperbolas that are centered at the origin, 0, 0. So really over there, the h and the k's would all be zeros, and you could just leave them blank, which is why they look like this, okay? In a horizontal hyperbola, the x is first in the equation, and the a is the horizontal distance from the center to the vertex of each hyperbola graph. B is the vertical distance to the edge of the rectangle to help draw the asymptotes. The slopes of the asymptotes are plus or minus b over a. I promise, I know it sounds like a lot to remember, but once you start working it, it's really not that bad if you just pay attention. Vertical hyperbolas, the y is first in the equation, and a is the vertical distance from the center to the vertex of each hyperbola graph. B is the horizontal distance to the edge of the rectangle to help draw the asymptotes, and the slopes of those asymptotes are plus or minus a over b. Okay, let's try an example. Go to the next page. Let's look at example 1. The directions say, write an equation for the hyperbola given in the graph. Then find the slope of the asymptotes. Okay, well first you need to identify whether it's horizontal or vertical. What is this hyperbola, horizontal or vertical? Horizontal. And the reason we know that is because it's opening right and left. And isn't right and left horizontal? Okay, since we know it's horizontal, that lets us know that we use this equation where the x comes first. So it'll be x squared minus y squared equals 1. And then over a squared and over b squared. Okay, well, if a is under x in this equation, isn't the a value going to be horizontal distance because x is horizontal? So from the center, from the origin, to the vertex of the hyperbola is how many units? Well, you got to look up there while I'm saying it so you'll see what I'm talking about. Right. From the center over to the vertex where it opens is 7 units, right? So that means your a value is 7. Then the b value for this equation is under y, and y is up and down. So to find the b value, we can go up or down. How far do you have to go up to get to that line? 3 units, so your b value is 3. So now when we plug those in the equation, a squared will actually just be a 49, and b squared will be a 9. That's only for ellipses. Okay, a no longer has to be larger than b. It was in this one, but that's not a rule for hyperbolas. We will get to some where the b is larger. We'll have some where they're equal. Okay, a is only greater than b in ellipses. Okay, so now before we move on to slopes and foci, let's go ahead and try to write the equation for example 2. Okay, example 2. Is this a vertical or horizontal hyperbola? Vertical, because we can see that those are opening up and down. And when it's vertical, doesn't that mean that we use the equation where the y comes first? So it'll be y squared minus x squared equals 1. But remember, with hyperbolas, A and B always stay in the same place. A is always here, B is always here. Well, we have to know what A and B are. Well, this time, isn't A up under the Y? So this time A is your vertical distance. And from the center up is how many units? 3. And then B is under X this time in the equation, so it'll be your horizontal distance. From the center over to the box is how many units? 6. So when you plug those in, 3 squared will be a 9, and then 6 squared will be a 36. No. Eventually you'll have to draw them in yourself, but it's easy, don't worry. Okay, you try example 3's equation. Try to write the equation for this hyperbola. Okay, is example 3 a vertical or horizontal hyperbola?
Horizontal.
Horizontal, which lets you know what?
Wait, what you talking about?
It basically tells you which equation to use.
Oh, the X.
The one where X comes first. Okay? And then so X squared minus Y squared equals 1. And then it's always A squared on this side, B squared on this side. Well, you have to know the A and the B. Right. Aren't both of them 2? So that makes it easy. So that means both of the denominators are? 4. Okay, now let's talk about the slopes. Okay, the reason it said on the first page that you do plus or minus for your slopes is because think about it. Don't we have one line, one asymptote line that's going up and another asymptote line that's going down? So that's why we have to have the plus or minus to represent the line going up and the line going down. Now, your slope is always going to be these two numbers. You just have to decide, is it 7 over 3 or 3 over 7? Well, look, to get from the center to this point on the edge of the box, do you go up 3, right 7, or up 7, right 3? You rise 3 and you run 7. So isn't that a rise of 3 and a run of 7? So in my opinion, instead of trying to memorize that horizontal or B over A and vertical are always A over B, it's almost going to be easier for you just to look back at it and calculate the rise over run instead of trying to remember the A over B stuff. Okay, so now let's look at example 2. You have 2 lines. You have a positive line and you have a negative asymptote line. So that's why you have the plus or minus symbol to represent both lines, the line going up and the line going down. You know that you're going to have either 3 over 6 or 6 over 3. Which is it? 3 over 6. Because think about it. To get from the center to over here, don't you rise 3 and run 6? Now on the test, that would be reduced to plus or minus 1/2. Okay, example 3. Why don't you try the slope of that? Okay, remember,
What?
it's plus or minus because you have 2 asymptote lines. You have a line going up and you have a line going down. That's why you have the plus or minus to represent each line. And then think about it. No matter what it is, it's 2 over 2. So that's not going to make a difference, right? Which simplifies to 1. And you can put over 1. I'm not sure on the choices if they would just put 1 or probably just 1. Okay, now let's try some of these. Go to page 3. We're going to wait. I don't want to overwhelm you. Okay, so right now we're going to do A and B. Okay, we're going to use the information provided to write the standard form equation of each hyperbola, and we're going to list the slopes of the asymptotes. Well, first of all, to know which equation to use, you have to figure out if it's horizontal or vertical. Which is it? Vertical. Okay, which means we're using the equation where what comes first? Let's continue. Now that I see that this is a vertical hyperbola because it's opening up and opening down, I know to use the equation where y comes first. So y squared minus x squared equals 1. And then it's always over a squared first and then over b squared. Okay, those stay in place with hyperbolas. It's these that flip-flop. Well, we kind of have to fill those in, so we have to know an A and a B. Well, I'll talk about that in a second. Okay. Eventually, you will start to see the box. It will just stand out to you. But this is how you figure out where it is. Okay, watch. If I go to the vertex right here, which is where it changes direction, and then I go to the vertex here, and I draw like from the vertex to the line, and then from the vertex to the line, and then you just connect those. Yep, that's how you create your box. Okay, eventually after you do enough of these, you'll just start to see the box. It'll just pop out to you. Okay, so we need to find the A value first. What is an A under Y? 2. So that means this time our A value is the vertical amount. So from here up is how many units? 5. And then B is under X. So this time B is your horizontal amount. So from here over is how many units? 4. So now that we know A and B, we can plug them in. So up under the Y squared, we'll end up having a what? 25. Because 5 squared is 25. Okay, and then this will become 16. So there's your equation. We've done A. That's part A. We wrote the equation. Now we need to do part B, list the slopes. Remember, you're listing the slopes of the asymptote lines, which are those lines that are drawn in 40. Well, isn't one of those lines going up, so it's positive, and the other line is going down, so it's negative? That's why you always have plus or minus on this number, because you have two different lines, a positive line and a negative line. And your slope will always include those numbers. You just have to decide which one's the rise, which one's the run. So to get from the center up to the corner, how much do you rise? 5. So that's your numerator. And then you obviously run 4. So the slopes of those lines are 5 over 4. Okay, now let's look at number 2. Are we dealing with a hyperbola that is vertical or horizontal? Right. This time it's horizontal because they're opening right and left, which lets us know we'll be using what equation? Right, the one where x comes first. I don't know if this will help you remember it, but Miss Young was saying sometimes she teaches her kids, like the horizontal hyperbola is like that, opening right and left. And doesn't that kind of make a fancy looking X? They're not always joined in the middle, obviously, but they open left and right, and so it kind of makes an X. If you're having trouble remembering, horizontal means X comes first. Okay, X squared minus Y squared equals 1. And then remember, it's always A squared on the left, B squared on the right. So we obviously have to plug in for A and B. Okay, but before we do that, let's draw in our box. Okay, remember it goes from line to line. And then from the vertex. Okay, so does everybody see how to draw in the box? Okay, now that you have the box, you can figure out the A and the B. The A is under X, so this time A is our horizontal distance from the center. So from the center to the side horizontally is how many units? 4. And then B is under the Y in this equation. So B is our vertical distance this time. So from the center up is how many units? 4 as well. So that makes the slopes easy. You don't even have to think about it. Both values are 4, so it's just plus or minus 4 over 4, which simplifies to plus or minus 1. Remember, you have to have the plus or minus. If you don't put that, you're not accounting for the negative line. There's a positive asymptote line, and there's a negative asymptote line. That's why there's a plus and minus. What? Yeah, go ahead and try number 3 by yourself. Okay, number 3. Is this hyperbola horizontal or vertical? Horizontal. Okay, hopefully everybody now can distinguish between the two. It's opening right and it's opening left, and right and left are horizontal directions. Once you know it's horizontal, you look to the board, or you'll look to your formula sheet once you have it, and you see that you use the formula where x comes first. Now, on the board it says x minus h, but think about it. Right now, this hyperbola is centered at the origin, so that h would be 0, and x minus 0 squared is just x squared. And then minus y minus k, which would also be a 0, so that's why it's just y squared. Not tomorrow, but the next day, we'll start working with hyperbolas that are not centered at the origin, and then you'll actually have numbers with the x and the y showing where it moved. Okay, now remember, it's always a squared at first and b squared second, so we need to figure out the a and the b, but before we do that, we need to go and draw in the box. Are the boxes starting to just kind of stand out to you?
Yes.
Okay, I can see that here's that line, and there's that line. Okay, so A is under x in this equation. So A is going to be our horizontal distance from the center. From the center over is how many units? 5. And then B is under y, which is going to be your vertical distance. From the center up is how many units? 4. So when we do our slopes, we know it's going to be plus or minus, and it's going to either be 5 over 4 or 4 over 5. We'll calculate. If you go up 4, so your rise is 4, and then you run 5. Remember, it's always rise over run. Okay, number 4, is this horizontal or vertical? Vertical. We have one opening up and another side opening down. So it's vertical, which tells you what? Right, the y comes first. It's y squared minus x squared equals 1. And so the a is under the y this time, the b is under the x. Okay, let me darken up the box in case you can't see it. You always define the box. You could start at the vertex. So you know the line will be right there where the vertex is, and it goes to the asymptote lines. And the same thing over here. Here's the vertex, so from the asymptote line to the other one. And then you just connect those. And that creates your box. Okay, so now, since A is under y, A is our vertical distance. So from the center up to the vertex is how many units? 3. Because look, there's number 4, so 3. No, you're right, aren't you? Let me look. No, it's 3. It's 3. Okay, yeah, because there's 2 and there's 4, so it went through 3. Okay, B is under the X. So this time B is your horizontal distance. So from the center over to the box is how many units? 5. So I know when I do my slopes, it's going to be plus or minus 3 over 5 or 5 over 3. You always have to use those numbers. So how much do we have to rise? 3. So that's your numerator, and then 5 is your denominator. Because you rise 3 and you run 5 to get from the center up here on the line. Okay, now turn to page 4.